AI is clearly emerging as a very key enabler of effective and cost-efficient air quality management. We know that in many geographies, there are multiple bodies responsible for dealing with air quality within government, outside government. So how can we use AI to bring it all together? Let me just illustrate this with a couple of examples. The first is, how can AI enable the decision support systems to actually hone in on where the problem is? Now, air quality data is coming from multiple different sources, from high-cost monitoring stations, from low-cost sensors, from models and forecasts, from emissions inventories, surveys, etc. Now, gathering all this information on one platform is one challenge. Making sense of it and making it salient enough to act is a different problem altogether. AI-enabled decision support systems can bring air quality managers closer to the action by eliminating the need for this complex analysis. Simple natural language queries could help them get the insight from this huge variety of information that is being collected. For example, my organization CEEW and IIT Gandhinagar are developing systems that can help them scale. We've, for instance, developed something called VayuChat, means air chat, which combines data from the Central Pollution Control Board air quality stations, the state level demographics, as well related to the National Clean Air Program, all on a single platform, but where the user can ask the questions in simple, plain English. For more advanced users, it will then expose the code behind the analysis. Our Clean Air team is also developing an AI-powered scenario tool that can then model the different pathways required to get to a desired air quality level. The traditional way, which is physics and chemistry-based models, are much more resource intensive. So you can make this more cost-effective. AI-powered air quality forecasting is going to be extremely important to save lives, reduce the vulnerability. Once the models are trained, they can then be deployed on modest computational resources for day-to-day operations. Again, for instance, CEEW and IIT Gandhinagar, we're working on making weather and air quality forecasts orders of magnitude faster compared to traditional methods. The deep learning emulators that we are developing could replace traditional weather forecasting model while being 3,000 times faster than the traditional model. And then you can detect forest fires, fugitive emissions, crop residue burning. You start pulling all of this together, you're doing it faster, you're doing it cheaper. The problem, however, is that like any technology, these are not 100% foolproof. Just consider this. If you have a tool that can detect stubble burning, right? And it has just a 1% false positive rate. So if you've then monitored 10,000 farmers or 10,000 construction sites, that error rate gives you 100 wrong answers. And then you've gone and deployed your enforcement officials in the wrong places. Just because we're leveraging AI doesn't mean you can just leave it to operate autonomously without the human checks as well, especially on sensitive matters like enforcement and penalties and shutting down economic activities, etc. When you put in those guardrails, that's how the confidence, not just in the technology, but in the procedures associated with the technology, will increase the confidence that regulators have, but also consumers and citizens have.